Hello everyone. Today we are going to analyze this beam using flexibility matrix method. Before analyzing, let us see the beam on time. In this beam there are three spans: span AB, span BC and span CD. In the span AB there is a concentrated moment 25 kN acting at 2 meter from the point A. In the span BC, there is a concentrated moment 20 kN acting in the center. Both of the moments are acting in the clockwise direction. In the span CD, there is a concentrated load 12.5 kN acting at 3 meter from the point C. In the points A, B and C, there are hinged supports. In the point D, there is a fixed support. Span AB is 5 meter long. Span BC is 4 meter long. Span CD is 5 meter long. In this beam, the number of unknown reactions and moments are 5. They are RA, RB, RC, RD and MD. The available equilibrium equations are 2. Sigma m is equal to 0 and sigma v is equal to 0. The degree of static indeterminacy is equal to 5 minus 2. We will get 3. From this beam, let us remove MB, MC and MD. When we do that, this continuous beam becomes 3 different simply supported beams. These beams are called the released structure. We have made the released structure. Now let us make the coordinates diagram. In this analysis, there are 3 coordinates. In the point B, in the point C and in the point D, we are having the coordinates. Because in these points only, we have removed the moments. Now let's see the formula to calculate the moments. P matrix is equal to delta matrix inverse into delta matrix minus delta L matrix. P matrix is the final moments or forces. Inside the P matrix, we will have the moments MB, MC and MD. Because these are the moments we have removed. Delta matrix is the flexibility matrix. Delta matrix is the final displacements. Delta L matrix is the displacement in the coordinate direction. Inside the P matrix, delta L matrix and delta matrix, there will be 3 values. Because in this analysis, there are 3 coordinates. In this formula, first let us find delta L matrix. Now let us make the ordinates. In the beam AB, a concentrated moment 25 kN is acting in the clockwise direction. It is not acting on the center. The formulas to calculate the ordinates are MB upon L and MA upon L. Here M is 25, A is 2, B is 3. After applying the values inside the formulas, we are getting the ordinates. On the left side of the movement, it will be negative. On the right side of the movement, it will be positive. Now, let us take the beam BC. Here, a clockwise concentrated movement is acting on the center. The formula to calculate the ordinates are m upon 2 and m upon 2. Here m is 20. Let us apply that. Finally, we are getting the ordinates 10 and 10. On the left side of the movement, it will be negative, and on the right side, it will be positive. Now let us take the beam CD. Here there is a point load 12.5 kN. This point load is not acting on the center. The formula to calculate the ordinate is WAB upon L. Here W is 12.5, A is 3, B is 2. When we apply the values inside the formula, we are getting 15. Now let us make the conjugated beams. In the conjugated beams, we have to divide the ordinates by EI. Now let's see how to calculate delta L matrix. In the delta L matrix, we have to find three values. Delta 1L should be calculated from the first coordinate, that is in the point B dash. Delta 2L should be calculated from the second coordinate, that is in the point C dash. Delta 3L should be calculated from the third coordinate, that is in the point D dash. Now let us calculate delta 1L. For that we have to find RB dash. RB dash should be calculated from the beams A dash B dash and B dash C dash. First let us take the beam A dash B dash and calculate RB dash. To calculate RB dash, I am going to take moment about A dash. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. RB dash is acting towards the point A dash in the anti-clockwise direction. So it will be positive. And the distance is 5 meter. So 5 RB dash. This UVL is acting in the clockwise direction, so it will be negative. For the UVL, we have to multiply the area with the centroid. In the right angle triangle, the area formula is half into breadth into height. The centroid towards the right is 2b upon 3 and the centroid towards the left is b upon 3. First, let us calculate the area. For this triangle, the centroid towards the left is 1 upon 3 into breadth. Here the breadth is 3. We are taking moment about A dash. So we have to add this distance 2 meter. So the centroid is 2 plus 1 upon 3 into 3. Let us eliminate this 3 and this 3. So the centroid towards the left we will get 3. Now let us take this triangle. This is also acting in the clockwise direction, so it will be negative. Since this triangle is below this line, we have to apply one more negative. So negative into negative, it will become positive. Then let us calculate the area. Then let us calculate the centroid. The centroid towards the left is 2 upon 3 into breadth. Here the breadth is 2. So the centroid towards the left is 4 upon 3. After the calculations, we are getting RB dash, which is equal to 65 upon 6 EI. Now let us calculate RB dash in the beam B dash C dash. To calculate RB dash, I am going to take moment about C dash. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. RB dash is acting towards the point C dash in the clockwise direction, so it will be positive and the distance is 4 meter, so 4 RB dash. This UVL is acting towards the point C dash in the anti-clockwise direction, so it will be negative. This triangle is below the line, so we have to apply one more negative. Negative into negative, it will become positive. For this triangle, we have to multiply the area with the centroid. The centroid towards the right is 1 upon 3 into breadth. Here the breadth is 2. Then we have to add this distance, that is 2. So for the centroid we are getting 8 upon 3. Now let us take this triangle. It is acting towards the point C dash in the anticlockwise direction, so it will be negative. Then let us calculate the area. The centroid distance towards the right is 2 upon 3 into breadth. So the centroid is 4 upon 3. After the calculations, we are getting RB dash, which is equal to minus 10 upon 3 EI. Now let us add both of the RB dash values. After adding, we have got 7.5 upon EI. Now let us calculate delta 2L. For that we have to find RC dash. First let us take the beam B dash C dash and find out RC dash. Here RC dash can be easily calculated by subtracting RB dash by the total load. This triangle is above the line, so the area will be positive. This triangle is below the line, so the area will be negative. Since both of the triangles are having the same dimension, the areas will be same. So when we subtract this area by this area, it will be 0. That means the total load is 0. 0 minus RB dash, we will get RC dash. Now let us calculate RC dash in the beam C dash D dash. To calculate RC dash, I am going to take moment about D dash. RC dash is acting towards the point D dash in the clockwise direction, so it will be positive, and the distance is 5 meter, so 5 RC dash. This UVL is acting towards the point D dash in the anticlockwise direction, so it will be negative. For the UVL, we have to multiply the area with the centroid. We know the formula for the area of a triangle, half into breadth into height. For this kind of triangle, the centroid distance towards the right is L plus B upon 3. Here L is 5, B is 2. So for the centroid towards the right, we are getting 7 upon 3. Finally, we are getting RC dash, which is equal to 17.5 upon EI. Now let us add both of the RC dash values. After adding, we are getting 125 upon 6 EI. Now let us calculate RD dash. RD dash can be easily calculated by subtracting RC dash by the total load. Here the total load is the area. The area minus RC dash, we are getting RD dash. In the delta L matrix, we have calculated all of the values. Let us apply them. 1 upon EI is constant. Let us keep it outside. We know that it is very difficult to calculate the reactions by taking moments. If you feel that it is very difficult, we can use the formulas and calculate the reactions. First, let us calculate RB dash in the beam A dash B dash. The formula is minus m upon 6L into 3a square minus L square. For AB, m is 25, A is 2, L is 5. When we apply the values inside the formula, we are getting 65 upon 6 EI. When we apply the formula, we have to be very careful. We have to divide the moment by EI. Now let us calculate RB dash in the beam B dash C dash. The formula is minus ml upon 24. For BC, m is 20, L is 4. When we apply the values inside the formula, we are getting minus 10 upon 3 EI. For delta 1L, we have to add these two values. After adding, we are getting 7.5 upon EI. Now let us calculate RC dash. First, let us calculate RC dash in the beam B dash C dash. The formula is ml upon 24. Using the formula, we can calculate RC dash. Now let us calculate RC dash in the beam C dash D dash. The formula is W upon 6 into L plus B. Using the formula, we can calculate RC dash. For delta 2L, we have to add these two values. After adding, we get 125 upon 6 EI. Now, using the formula, let us calculate RD dash. The formula is W upon 6 into L plus A. By using the formula, we are getting RD dash. So, using the formulas, we can easily make the delta L matrix. In this formula, we have made the delta L matrix. Now, let us find the delta matrix. Same like delta L matrix. Inside the delta matrix, there will be three values. All the values are 0 because in the given beam, there is no overhanging. In this formula, now let us find the flexibility matrix. Let us see the size of the flexibility matrix. For 3 coordinates, it will be 3 by 3. For 2 coordinates, it will be 2 by 2. For 1 coordinate, it will be 1 by 1. In this analysis, there are 3 coordinates. So, the size of the matrix is 3 by 3. Now, let us calculate the first row in the flexibility matrix. For that, we have to apply unit moment in the first coordinate. When we apply unit moment in the point B, here the moment will be 1 and here it will be 1. Using that, we can make these diagrams. We know that in the conjugate beam, we have to divide the moment by EI. Now, let us calculate delta 1, 1. For that, we have to find RB dash. First, let us find RB dash in the beam A dash B dash. We can apply the formulas and calculate the reactions. For the minimum loading side, the formula is WL upon 6. For the maximum loading side, the formula is WL upon 3. Now we are going to calculate RB dash in the maximum side. The formula is WL upon 3. Using the formula, we are getting 5 upon 3 EI. Now let us calculate RB dash in the beam B dash C dash. Here also the formula is WL upon 3. Using the formula, we can calculate RB dash. Then let us calculate RC dash. The formula is WL upon 6. Using that, we are getting 2 upon 3 EI. RD dash will be 0 because there is no loading in the beam C dash D dash. For delta 1, 1, we have to add these two values. After adding, we are getting 3 upon EI. For delta 1, 2, we have to apply this value. Delta 1, 3 is 0 because RD dash is 0. Now, let us find the second row in the flexibility matrix. For that, we have to apply unit moment in the second coordinate. I have applied unit moment in the second coordinate. After applying unit moment, we can make these diagrams. First, let us calculate delta 2, 1. For that, we have to find RB dash. The formula to calculate RB dash is WL upon 6. Using the formula, we can calculate RB dash. Then let us calculate RC dash in the beam B dash C dash. The formula is WL upon 3. Using that, we are getting 4 upon 3 EI. Now let us calculate RC dash in the beam C dash D dash. Here also we have to use the same formula WL upon 3. Using that we are getting 5 upon 3 EI. Now let us calculate RD dash. The formula is WL upon 6. Using that we are getting 5 upon 6 EI. For delta 21, let us apply the value of RB dash. For delta 22, we have to add these two values. After adding, we are getting 3 upon EI. For delta 23, we have to apply this value. Now, let us make the third row in the flexibility matrix. For that, we have to apply unit moment in the third coordinate. When we apply unit moment in the third coordinate, here the moment will be 1 and here it will be 0. Using that we can make the diagram. Let us calculate RB dash. In the beams A dash B dash and B dash C dash, there is no loading. So RB dash will be 0. Now let us calculate RC dash. The formula is WL upon 6. Using the formula, we are getting RC dash. Now let us calculate RD dash. The formula is WL upon 3. Using the formula, we are getting RD dash. Delta 31 will be 0. For delta 32, we have to apply the value of RC dash. For delta 33, we have to apply the value of RD dash. In the flexibility matrix, we have calculated all of the rows. Let us apply them. 1 upon EI is constant. Let us keep it outside. In this formula, we have calculated all of the values. Let us enter them. 1 upon EI inverse is equal to EI. Then let us add these two matrices. After adding, we are getting this matrix. We can eliminate this EI and this EI. For this matrix, we have to find the inverse. We can apply all of the values in the calculator and get the inverse. I have used the calculator and got the inverse. After multiplying these two matrices, we are getting the final moments. In this analysis, we have calculated all of the moments. Now, we are going to calculate the vertical reactions. First, let us take the span AB and calculate the vertical reactions. In the span AB, there is only one moment, MB, which is acting in the clockwise direction. In this span, first I am going to calculate RA. For that, I am going to take moment about B. In this case, I am moving towards right hand side. Clockwise will be positive and anticlockwise will be negative. RA is acting towards the point B in the clockwise direction, so it will be positive, and the distance is 5 meter, so 5 RA. Then there are two moments, 25 and 1.66. Both of them are acting in the clockwise direction, so both of them are positive. Finally, for RA, we are getting 5.33. For RA, we got a negative value. That means our assumption is wrong. We assumed that RA is acting upwards, but actually it is acting downwards. Now let us apply the rule summation of vertical forces is equal to 0 and calculate RB1. In this span, there are two vertical forces, RA and RB1. We know that RA is acting downwards, so it should be negative. RB1 is acting upwards, so it should be positive. Here, let us apply the value of RA. In this way, we can calculate RB1, which is equal to 5.33 kN. Now, let us take the span BC and calculate the reactions. In the span BC, there are two moments, MB, which is acting in the anticlockwise direction, and MC, which is acting in the clockwise direction. In this span, first I am going to calculate RB2. For that, I am going to take moment about C. RB2 is acting towards the point C in the clockwise direction, so it will be positive, and the distance is 4 meter. So for RB2, then there are three moments. 1.66 moment is acting in the anticlockwise direction, so it will be negative. The moments 20 and 3.76 are acting in the clockwise direction, so both of them are positive. Finally, we are getting RB2 5.53 kN. For RB2, we got a negative value. That means our assumption is wrong. We assumed that RB2 is acting upwards, but actually it is acting downwards. Now, using the rule summation of vertical forces is equal to 0, we can calculate RC1. After applying the rule, we are getting RC1, which is equal to 5.53 kN. Now, let us take the span CD and calculate the vertical reactions. In the span CD, there are two moments, MC, which is acting in the anticlockwise direction, and MD, which is acting in the clockwise direction. By taking moment about D, we can calculate RC2, which is equal to 3.73 kN. By applying this rule, we can calculate RD, which is equal to 8.77 kN. In the point B, we have calculated the reaction two times. Let us add both of them. After adding, we are getting 0.2 kN. For RB, we got a negative value. That means it is acting downwards. For RC also, we have calculated the reaction two times. Let us add the values. After adding, for RC, we are getting 9.26 kN. Now, we are going to draw the shear force diagram. Before drawing the diagram, let us calculate the shear force values. I am going to calculate the shear force values from the point A and towards the point D. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. You can see the shear force calculations. Using the values, we can make the shear force diagram. Now, we are going to draw the free movement diagram. For drawing the free movement diagram, we have to consider every span as a separate simply supported beam and calculate the moments. In this analysis, we have already calculated the ordinates in the beginning. Now, using the end moments, we can make the end moment diagram. Then we have to combine the free movement diagram and end moment diagram. So we will get the bending moment diagram. Now we are going to end this session. Thank you for watching this video.